Today we're going to be looking at multiplying powers with like bases and powers of powers. In other words, an exponent to an exponent. None of this should be new for you. You should have had this last year. Remember, when you're multiplying powers with like bases, if you have any coefficients, you multiply the coefficients. With your variables, you keep the base and add the exponents. So the rule is, if you are multiplying two variables together, you keep the base and you add your exponents. You are not allowed to have negative exponents as answers. All of your answers should have positive exponents. Okay, so let's look at number 1. We have 12 to the 4th times 12 to the 3rd. We've got the same base, so we keep the base 12 and add the exponents. 4 plus 3 is 7. We're not going to simplify 12 to the 7th because the directions will say leave your answer with positive exponents, so we can leave the answer like that. In number 2, notice we have the same base, a base of negative 5, and we add the exponents. Negative 2 plus 7 is positive 5. And again, we're not going to find the value of that right now. In number 3, again, the same base, so we're going to keep the base 0.5 and add the exponents. Negative 3 plus negative 8 is negative 11. Now I've got a negative exponent as an answer and I'm not allowed to have that. So if you remember from yesterday, when we have a negative exponent, we have to move it down into the basement, down into the denominator. Now there's a value in the numerator which is going to be a 1. And remember, we move the value down into the denominator, the exponent becomes positive. In number 4, again, we have the same base 9. And we add the exponents. Negative 3 plus 2 plus 6 is positive 5. And again, I don't need to find a value for that one there. Now number 5 is different because number 5 has coefficients. We've got a 4 and a 9 as coefficients. So I multiply the coefficients, keep the base of z, and add the exponents. 5 plus negative 12 is negative 7. And once again, I end up with an answer that has negative exponents, which is not allowed. Notice it's only the z that has the negative exponent. So it's only the z that moves into the denominator. Once he moves to the denominator, the exponent becomes positive. The 36 stays because he doesn't have a negative exponent. The negative exponent belongs to the z only. In number 6, I multiply the 2, the 9, and the 3 to get 54. Now notice in number 6 I've got different variables for the bases. So I'm going to look at the a's first. I keep the base of a and add the exponents. There's an invisible 1 on the first a, so that's a to the 3rd. There's nobody to multiply the b with, so I'm going to leave it as b to the 4th. No negative exponents in that answer, so I can leave that as my final answer. In number 7, I've got 5 times 1 times 3, which is 15. And I've got bases of x, so I keep the x and add the exponents. And again, I have an invisible 1 with that 3x. So 4 plus 9 plus 1 is 14. And again, I don't have any negative exponents that I have to worry about. In number 8, I multiply my coefficients, negative 4 times 7 times 2 to get negative 56. I've got like bases of c to the 3rd and c to the negative 2, so I keep the base, add the exponents. And there's nobody to multiply the d squared by, so I'm just going to bring them over. Now, you don't have to have the exponent of 1 there. As a matter of fact, you shouldn't have the exponent of 1. So we're going to have negative 56c d to the 2nd. I wouldn't mark it wrong if you leave an exponent of 1, but towards the end of the year I will, because there's no reason to have that 1 there. Number 9 only has a coefficient of 12, so I'm going to keep the 12. Notice I've got j's, so I've got j to the 2nd times j, which is j to the 3rd, and then k to the negative 2. There's nobody to multiply the k by. But notice that k has a negative exponent, so I can't leave that as an answer. The k is the one that has to move to the denominator because k is the only one with a negative exponent. The 12j to the 3rd stays in the numerator because he doesn't have any negative exponents. Okay, so remember, multiply your coefficients, keep the base of the exponents, and then add your exponents together. Okay, on the next page, now what happens when you have a power to a power? And this happens when you have an exponent raised to another exponent. The rule is that you multiply the exponents together. Again, you keep the base and multiply your exponents. So if we look at number 1, I've got n to the 4th power raised to the 7th power. I've got two exponents there, a power to a power, and what we say, a power to a power is a product. So it's n to the 28th power, because 7 times 4 is 28. Now, you actually have an option of writing n to the 4th out 7 times. You can say n to the 4th times n to the 4th times n to the 4th times n to the 4th and do that 7 times and add your exponents, but it's easier just to use the power to a power as a product. So again, power to a power, keep the base, multiply the exponents. In number 3, power to a power, keep the base, multiply your exponents. 1/2 times 1/4 is 1/8, so it's p to the 1/8 power. Now, number 4 is a little bit tricky because we've got two different operations going on. We've got multiplication here, and we've got a power to a power here. And if you remember your order of operations says that we have to do exponents before we do any multiplication. So I'm going to keep the x squared for now, and I'm going to take care of my power rule. Power to a power is a product. So I keep the base, x, and multiply 6 times -4, which is -24. And now what I have is multiplication. And remember from the first page, the rule is keep the base and add the exponents. So -24 plus 2 is -22. And again, I can't leave a negative exponent as an answer, so I move it to the denominator. There is a 1 in the numerator of that fraction. We can't forget that. Number 5 is again the same idea. I've got multiplication, but I also have a power to a power. So I'm going to hold off on the multiplication right now because our order of operations says I need to do exponents first. And then 5/3 times 3 is 5. So keep the base, multiply the exponents. Now that I'm back to multiplication, I keep the base and add the exponents. And notice I don't have any negative exponents to worry about. Now, number 6 has two terms inside the parentheses. So what you have to know is that that exponent has to go to both terms inside the parentheses. This is really 3 to the 4th, x to the 4th. And the reason that is because if I take this base and multiply it out the number of times the exponent tells me, I have 3x times 3x times 3x times 3x. So I have to do 3 times 3 times 3 times 3. Now this one we are going to simplify because 3 to the 4th we can easily find as 81 x to the 4th. And again, no negative exponents to worry about. Now number 7, I've got 5x to the 3rd raised to the 2nd power. So I can write 5x to the 3rd out twice and say 5 times 5 is 25. And x to the 3rd times x to the 3rd is x to the 6th because I add exponents. Or the shortcut is that exponent goes to each term. So it's 5 squared. And when I have a power to a power, I multiply the exponents. We get the same answer either way. So if you like to write it out, this is a longer method, you can write it out. Or it's a good way to double check that your answer is correct if you use the shortcut of multiplying your powers. Okay, number 8 is the same idea, so I can write out 7m to the 9th 3 times. Or the shortcut is to say 7 to the 3rd, m to the power to a power is a product, m to the 27th. And we can find 7 to the 3rd, which is 343. M to the 27th. Now, if you're told to find the value of a number, then we are going to have to actually do the multiplication like 7 to the 3rd. But if you're just told to simplify, then you don't have to. You can leave it as 7 to the 3rd. Okay, now we can do a couple different things with this one. We can use the shortcut, 2 to the -4, z to the -4. Now notice that both of those have negative exponents. So both of them are going to move to the denominator. And when they move to the denominator, everything becomes positive. And now we can actually do the math. 2 to the 4th becomes 16. So we have 1 over 16 z to the 4th. Now what I could have done in the beginning was I could have said, okay, well I have a negative exponent, so the whole base moves to the denominator and the exponent turns positive. And then I just have the same problem. I'm just working in the denominator rather than a numerator like I did originally. I prefer to give the exponent out first because that way I don't lose my numerator when I'm working on the problem. Power to a power is a product, so g to the negative eighth. Notice both of those terms have negative exponents, so both of them move to the denominator. So this becomes 1 over 9 g to the eighth. Okay, number 11, we have a lot of stuff going on in number 11. We've got a power to a power for two different things, and we have multiplication. We have to multiply the first term, x to the negative 2 squared, times the second term. But order of operations, remember, tells us we have to do exponents before multiplication. So the first one, x to the negative second squared, remember, power to a power is a product. And then we're going to multiply that by, and now we have an exponent on the outside, so I have to give that exponent to every term on the inside. Remember, you're multiplying your powers, so 5 times 4 is 20. Now I can simplify this because I can do 3 to the 4th, and notice I have like bases now, x to the negative 4 and x to the positive 4. When I'm multiplying, I add the exponents. Negative 4 plus 4 is 0. And I'm going to simplify that one step further, and I'm going to say that 3 to the 4th is equal to 81. X to the 0 is 1, so I'm multiplying this 81 times 1, which is still 81. So x to the 0 goes away. Okay, same idea in number 12. I have an exponent on the outside that I have to give to both terms, so this is going to become 3 to the 4th. C to the, now again, power to a power is a product, so I'm going to multiply 5 halves times 4, which is 10. And then I'm going to multiply that by c to the 6th, because I have a power to a power that I need to multiply. Over here I have like bases again, so I'm going to do 3 to the 4th, which is 81. And keep the base of c and add the exponents since I'm multiplying. Same idea for number 13. Everybody's going to get that exponent of 3. So 6 to the 3rd, a to the 3rd, b to the 3rd, times 5 squared a to the negative 6. Because I'm going to distribute those exponents to everybody inside. Now 6 to the 3rd is 5,400. I'm sorry, 6 to the 3rd times 5 squared is 5,400. Notice I've got like bases here, a to the 3rd and a to the negative 6. I keep the base, add the exponents. B to the 3rd doesn't have anybody to multiply with, so I'm just going to keep him b to the 3rd. Now there's only one negative exponent in this problem that I have to worry about, so it's only the a to the 3rd that's going to move to the denominator. Everybody else, 5,400 and b to the 3rd, stay. Okay, now what we're going to do is look at doing scientific notation and exponents in the calculator. When we're doing scientific notation, remember we want to put our calculator in scientific mode. So if you press the mode button on your calculator and go to SCI, and that way we'll give our answers in scientific notation automatically. And to do these problems, all you need to do is enter it in your calculator exactly the way that you see it. You're going to type in a left parenthesis, 3 times 10 to the 8th. Make sure you scroll down, close your parenthesis, and then do another exponent of 2. When you hit enter, you should see 9e16. And remember that 16 means times 10 to the 16th power. So in number 15, again, you're just going to enter it in your calculator exactly the way that you see it. 3 in parentheses, 3.1 times 10 to the 3rd. Close your parentheses and give it another exponent of 4. And you should come up with 9.23521. And it says E13, which means times 10 to the 13th. With any remaining time left, you're going to be working on your homework.